today we are going through a demonstration on how to set up a local EGA demonstration. And I wanted to just start. So I'm Alexander Sens. I'm one of the programmers who wrote this local EGA demo. I just wanted to go through what we are expecting to see in today's demonstration. Okay, so the local EGA demonstration that we have created is based on Docker containers. And we have done that for one reason, because we're switching to Docker ourselves at the moment. But another reason is it's a very easy way for us to decouple the system from the underlying host system specifics. So ideally, whatever we show today should run on any machine capable of running Docker containers. It is not limited to what we are showing here. However, in order to provide a common system for us to show this demonstration, we're using an Ubuntu-based VM to install this later on in this demonstration. So one of the first things that this demonstration entails is to download the code that runs this. So we are providing on the GitHub a code base. We download this, and this will then actually contain all the code and all the configuration files necessary to run this demo. So this code is deliberately kept separate from the Docker containers. It will be accessed from the Docker containers, but it is actually not inside of them. One thing you'll notice is that the directory is divided into a main public and a private branch, and this is done primarily to sort of indicate how an EGA vault might be set up. So if you look at maybe a logical view of what an EGA vault might look like, first of all, everything is in a specifically firewalled or in another way secured area. However, within this vault itself, there's also a more public and an extremely private area. So this is necessary because we have some interaction with the outside world. That is, we have to receive submissions via FTP boxes. And we also have to be able to provide data for download. So there is some public interaction with these machines. In order to keep the archive extremely safe, this is on an entirely separate subnet, which can only be accessed from other machines within this vault. And so this separation into public and private directories is an indication of that. Of course, in this demonstration, it's not as secure as that. For production deployment, you would probably want to do something like this. Also, I'm not sure how much you're familiar with Docker itself. Just as a very brief Docker introduction, what Docker provides us is to create an environment that is stable for one, and for another, it provides everything necessary to run the code we have. So any libraries, any installations, all of that can be packaged into a Docker image. And what that then is just code that sits on your hard drive with all the code to run the programs in the end. In order to get use out of them, we have to run an image, and that creates a Docker container. So the container adds to this image a writable file system, as well as the ability to run code. So every Docker container basically has its own file system, and the image remains unchanged. That means we can run multiple containers off a single image without modifying it. One thing that can be done when you run a Docker image is to link directories that are outside of this container internal file system. So not no, can't. It's not. No. So I can't zoom in any further. I'm afraid that's the furthest that we can zoom in, I'm afraid. Unless Okay, so one thing that Docker allows us to do is to map internal directory paths to external directory paths, meaning I can map a directory on your host system into a Docker container. And we're going to use that in order to access our code, which is hosted external to the containers. However, in order to ensure that all the Docker containers we create have an identical interface with the host system, we're going to standardize them. That means there will be 2 containers which perform this mapping, and those are the only 2 containers. Everything else then refers to those. And so the first thing we're going to do is create 2 data-only Docker containers. Those will not run any code, but will map directories. So for example, the first data-only container will map the path home, EGA local public on the host system, into the container internal path, which is simply EGA local public. So whatever the external path is, if you map that to this internal path, then everything else will run. This is one of several mappings that is done in this. And then we're doing similarly one for the private area of the vault. So these are our first 2 Docker containers, and they act as an interface to the host system. They're not running any code yet. Once we have done that, the next thing that an EGA needs is a database, and we have decided to use a Postgres database. Here we don't have to do much because there are Docker images on the Docker Hub which have done that for us. All we have to do is run one of these images, which will then download it from the hub, create a Docker container, and we have a running database server. So this will then create a database server which we named EGA Pro, which links to the directories in this data-only container, EGA Private. The next thing we'll have to do is to run Perl code. Now, we want to make sure that the Perl code we run at all times has the correct environment. And to that end, we are building our own Docker image that that installs just the right code and libraries, and also the interaction with the database. So this is also done to abstract the execution environment from the host system. This creates an image for Perl, and once we have done that, we are able to run 2 scripts. In this case, we are going to create and populate the EGA Pro database, and we'll add some demo information into that as well. In the deployment view, this looks like this. So a Perl container is created. I'm going to run then inside of that a script. And when it's done, I'm actually removing this container again. So this is what we call a transient container. This is only necessary for the execution of this particular script. And we're running 2 scripts, so 2 of these containers will be created and then removed again. And at that point, the database exists. You could then connect to the database using a standard database viewer on your host system. And you can do that because every Docker container on your has its own IP address. So there's ways to figure out what the IP address is. If you follow these instructions, the database server will run on 172.17.02 on the standard port. You can just connect to it just like to any other Postgres server. So we have a database. The next part of EGA is the cryptographic encryption and decryption code. And the way we have dealt with it at the EGA is we have collected everything we need into a single REST service. We call it our Cypher resource. And all that is basically a private REST service that allows us to perform all the cryptographic operations we need. You specify a source encryption, and a destination encryption, and the service performs this action. During submission, this performs it decrypts the GPG public key encrypted files submitted to us and re-encrypts them in AES-256 format using an encryption key, and it calculates the MD5s along the way. So at the end, I have the unencrypted MD5 as well as the MD5 of the re-encrypted file, and it all happens in a single step. And similarly, when I download data from the archive, This automatically decrypts the AES-256 archive format and re-encrypts it with AES-128 using the key that a user has provided to us during the download operation. This is all encapsulated into the archive Docker container. Here I'm linking both public and private areas, and I also make sure this can access the EGA Pro database. One of the way this REST service is created is when you run the Docker container, it starts a monet process, which in turn starts the REST service. And you can look at the monet process by looking at the HTTP interface that is exposed by it. So this is the next Docker container we created. So in our case, the IP will be 172.17.03, and the port for the monet is 8103. So you can later go to a web browser and monitor, make sure that the service is actually running what it is doing at the moment. So similarly, now that we have the cryptographic resource, we can create the download API. This is one container which will run 4 microservices. 2 of those are public-facing. There is the login and session management service. There is the download service. And then behind those, I have a database interaction service, which performs most of the database interaction, as well as a configuration service, which also performs some logging. So this API, in the end, is what the download client then interacts with. So here it is. API as a separate Docker container, links to the archive, to the database, as well as to the public side of the vault. So at this point, we have basically an archive and a way to access the archive. What is missing now is to be able to submit files to the archive. So the next few steps, we're going to install an FTP server so that we can submit, and then run an actual demonstration of how to submit a file into the archive. So FTP server, that is, again, an existing Docker image, so all we have to do is run it. There's nothing else necessary. We will then create a user inside of this FTP server. Then we allow downloading a file from ENA, just a public file which we have chosen as our demonstration file. Calculate the MD5. We encrypt this file using the public key of this virtual machine. And so this is something we packaged with the code base, just a demo public-private key pair. Calculate the MD5 of the encrypted file. Submit the encrypted file and those MD5 files using the FTP server, and then run the Perl script to archive it, which verifies submission, re-encrypts it, and inserts it into the database. Once that is done, so you can see the submission script. Again, it's a transient Perl container which links to all of the rest of the infrastructure we just created. And once you have done that, you can then install Java and run the download client to download this file, or you can access it directly with a fuse layer. So the fuse layer is now a way which allows you to directly use the files in your archive without having to copy and decrypt them. But this is basically what we're aiming to demonstrate here in this webinar. Thanks.
Okay, good afternoon, everyone. So my name is Chamida King. So I just want to start off just by saying that I'm a user support officer at the EGA, and this is a non-technical role at the EGA. So I deal with users on a daily basis to resolve issues regarding submissions and data access and so on. I've had no part to play in the development of this local EGA. In fact, I was only exposed to some of the scripts and the commands over the last couple of weeks. So what I'm going to do is I'm going to basically take you through the whole process. So this will be a demonstration from our side, and it's basically a six-stage process, which takes you through right through from setting up to actually testing the actual system, as Alexander said. So I will only be giving you a general overview of the actual commands as we use them. There is further documentation available on the GitHub website, and I will show you how we can access that GitHub documentation. And that gives you a full overview, a full detailed view of each command and what it actually does. If you have any issues regarding the local EGA setup, or you have any further questions, there'll be an opportunity at the end of this webinar. But we'll also take any queries that you wish to submit to EGA Help Desk. If you just put a subject heading local EGA setup issue, and we'll look into the issue as soon as we can. Okay, so to start off with, I'm assuming that you all have a setup of Ubuntu already on your system, using this the latest version of Ubuntu, and also that you have a VM also set up and installed on your system. So this is a an assumption that you already have all these things in place. So going forward, the very first thing that we need to do is to download the EGA codebase, and we can do this from GitHub using this URL here. So I'm going to do this now. Okay, so here you can see that there are a total of 5 codebase files, so we're going to download each of those files. Also, I want to point you to the local EGA setup PowerPoint here. So this is the document that you can look in, which gives you a detailed overview of each individual command. And indeed, the presentation that I will be going through and using is basically a subset of that presentation. Okay, so I'm going to download all of the EGA codebase files. Okay, so it should be finished in about 2 minutes. Twice. Okay, so we're nearly there, halfway there. Okay, so Okay, so those have been downloaded and extracted. So if I then open up a terminal window, okay, so what's it downloads? Okay, so I've just moved them into my home directory. So here they are. So what I'm now going to do is I'm just going to extract them using this command. Cat. It's not right. What's that one? For some reason, hang on, bear with me. Should work. Okay. There we go. And then if I then cd into the EGA local directory, and do a list, you can see that we have a number of directories. So we have this private and public directory that Alexander spoke of, and also you have a directory containing all the setup scripts that we'll be referencing as we go along as we set up this local EGA system. The next thing we have to do is we have to then set up our Docker directories. So we do this first by installing the Docker actually onto the host VM by using this command here. Start it again. Change the format. Which one?
Update.
This one.
Update.
There we go.
No, update.
Whoop. There we go.
Submit.
So. Okay. To this. There we go. Okay, so that's run in, and then we need to set the user. So if we use this command here, it means that we don't have to do the sudo command every time we type a command. So we'll do that. There, and it's changed. Again. That's it. Docker. That's it.
Before the
18.
After the Docker.
Okay. And then for the changes to make effect, we then need to log out the VM and log back in again. Okay. So I cd into the local EGA again. we go. And what I'm going to do is we're going to be using a file that we're going to upload to our local EGA. And we're going to start that download now because it's quite a large file, so it can be downloading whilst we go through the process. So I start opening a new tab, and the file is located here. So if I do this, is going to change the isn't it?
Maybe use your text file.
Yeah, I think. This, I'm just going to refer to my text file because the presentation seems to be disrupting the formatting of the text. So if I go to my, there we go. Okay, so that can be downloading what we go through the rest of the setup. The next thing we need to do after we've done that is to set up our Docker directories. So these are the public and private Docker data-only directories. So we'll do that now. So I'll just go to these two commands. There we go. So I'll set up the public one first.
So this image is based on a CentOS image, which is downloaded now from the Docker Hub, and then it's instantiated with directory mappings.
Okay, so I'm going to then do the private data-only container, and that's there as well now. Okay, so having done that, the next thing to do is to basically set up the EGA database. So to access the EGA database and to use the EGA database, as Anthony previously said, we need to set up a Postgres SQL and also build a Perl image. So we'll do those things first. So we've set up the Perl image here. Oh, sorry, the Postgres component here. I'm running this command.
So this again, it downloads the existing Postgres image from Docker Hub, and once it's completed, it will run it and create a Docker container which runs Postgres, an empty database at this point.
And then we will build the Docker Perl image as well, once that's finished. Okay, so the next is the Perl image. And once that's finished, we can then start to actually create our EGA database and then populate our EGA database using these two commands here.
So what is happening at the moment is we have downloaded the base Ubuntu image. We're upgrading it to the latest version of all the code. And then we are installing the Perl components and the database interaction components. and then the image is complete. You do that once, and every time you use this image, it's already there.
Okay. So this is probably the longest step.
Yes. Apart from downloading the
Can we have questions already now?
Yeah, sure.
Why do we have to build this image and the others you can pull from the Docker Hub?
This creates an environment that is able to execute the Perl code and also interact with the database we have installed. So we have in the past run into issues where the version of various Perl libraries was incorrect, which caused errors in the way the scripts were run. By creating this image, we have a stable execution environment, and every Perl script runs in a predicted way.
You could upload the image to Docker Hub as well, right?
Yeah, that's correct. You
Okay.
probably should do that soon.
Mm-hmm.
And another question, another related question, why does this have to be a separate image? Why does the Perl has to be a separate container? Why is it not included in the local EGA image? Because in my opinion, having too many containers like this, it destroys the idea of containers as a whole. So why does this part need to be in a separate container? Can it be included in the local EGA or other of the many containers that you have at the C?
Well, it is at the moment just an image, so it's not running anything. It will be instantiated for every time we are running a script. So it can't be, it could be included in another image, that is correct. But this is our first version of this code, and this was the best way we came up with running it at the moment.
Okay, so that's now finished, so I'm now going to create the EGA database.
Oh, we use EGA Pro for that.
Yeah, EGA Pro. Okay, and then we're going to populate the database. Okay, so that's done. Database has been set up. So at this point, you can actually use a database viewer such as dbeaver to actually access the database. So there's login details, or the connection details are here. They're also the connection details are also in the PowerPoint presentation that I pointed to on GitHub. So the next step, stage 3, is to actually build this EGA Cypher resource. So the first thing to do is actually to create the CentOS image. So do that using this command. Yeah.
So the reason we are building a custom image for these is that this is the only image where I have to include some customized code, and that is to enable an auto start of these containers. So the piece of software that is going to be inserted here is a monet.rc file, which is a configuration file for Monet, and that will then be used to automatically start the Cypher mini service or microservice upon startup of this container. And because it was developed in CentOS, I based my image on CentOS. That's the only reason, but that probably could be streamlined a bit.
And once that has finished, we need to then instantiate the image. Okay, so I'll do that now. So we have the encryption service set up. We now need to actually build the EGA download API so that we can access the files that we upload into our archive. So we're going to use a Docker build to build the image. Again, instantiate it. So at this point, we have a database called EGA Pro built and created and set up. We have a re-encryption resource, and we also have now a working download API. So we can actually look at these services by doing a docker ps-a. And you can see that the services are running. You can see when the service was created and how long they've been running for, or the status of the service itself. As Alexander has already said, another way that you can monitor the service is by using a Monet. You can invoke this by going to the web. If I open up the website. Why is it not working? Okay, hang on a minute. Okay. So username?
EGA. EGA local password.
Okay. And here you can see an overview of the services in place as well.
So what you can see, what I'm monitoring here is the process itself, res 9124. This makes sure that the process is up and running. I make sure the host is up and running by actually performing a REST call against the service. So it is possible that the service is running but unresponsive, but the REST call would detect that. I'm also checking the system itself up in the local, as well as the network status to show me what is happening on the network interface of this particular node.
So this is an IP of a running container, right?
This
Monet.
I'm using Monet inside the container. So the container will start the Monet, and Monet then in turn will start my process. And you can verify that the process inside of this Monet container or inside of this Docker container is running. by going to the IP of this container, which is 172.17.03.
This was my question. Yeah, thanks.
Okay, yeah.
Okay, so we have those services in place, but currently we have no means of actually uploading any files to the service. So we need to add an FTP server. So again, we use the docker run command for this purpose. And after that's run, we need to actually create an FTP user. So we have to do this within the FTP server.
So in our institute, we are not allowed to have any FTP service. Is it possible to have a FTPS or SFTP or something like this in the future, or how dependent is it, let's say, on FTP?
Not at all. As long as
okay.
you can get files into a specified location, that is all that is necessary.
Okay, thanks.
Third of the speed.
Yeah. Okay, so now onto the FTP server, and then what I need to do is I need to create this user. I'm going to create a user called Bob. Define my password. And then complete the creation of the user. And then exit. So I can test the FTP connection by doing a grep. Which should give me the IP address of 172.17.05. And just to confirm, I can log into the server. There you go. You can see that I've now logged into the FTP server under the username Bob and my password. So the next thing to do is actually to test the system. So we need to.
One question before we proceed. This the question that you received about using SFTP instead of FTP. So if you go to the previous slide where you have the Docker command for running the FTP container.
Sorry.
The previous slide where you have the command for running the FTP container.
Yep.
Yes.
Yeah. So I see here this one. You are using Stillard / pure FTP D.
Yes.
So I'm not sure if this is an official image, but is this something that you created, or it is something from the Docker Hub?
It is something from Docker Hub. So this is something we didn't create our own FTP server. We just use one that is available.
Okay, so it means that if I use an SFTP or FTP, any SFTP or FTP image from the Docker Hub, this should work with
Yes.
this. Okay.
Yes. As I mentioned before, the main point is for you to be able to get files to a certain submission directory. And you can do that any way you want. It doesn't have to be FTP, but as long as you have the ability to receive files and store them in one of your directories, that's what's crucial. The
Okay.
method.
Yeah, this is all of it. So there is no security dependency, anything special that you installed in this image. It is just, this is the whole purpose of it, right?
Yes. And we're also not using these upload users for anything other than allowing you to upload something. So this is in no way related to the EGA user later on. Those are completely two separate.
Okay.
Does anyone at this point have any further questions? It appears the file that we're downloading is taking some time. The connection speed is much slower than what we expected. So it may be that I will have to log into another VM where I know that file can be found. But do we have any more questions at this point whilst I log out of this VM?
I have something, it's not a question, but maybe a request, and I think maybe interesting for the others also. So I saw that you are having a text file called commands where you are copying things from.
Yes.
Is it possible to share that?
Yes, of course. I mean, the commands themselves can be found in the PowerPoint documentation on GitHub. So I took them directly from there.
Yeah, but having the text file is...
Okay, yeah, I'll upload them to GitHub.
And also, there is something like, for example, when Alexander described about why we made this as a container, why we had to have a CentOS image. So because I see that you're having many containers, I'm not sure how many containers in total you will have, maybe more than 10 at the end. So we have competence in this. We can help you to develop it better if we know that, for example, this CentOS image, it was not developed for security reasons, but for technical reasons, then we might help you to develop it more. So if you add this to the document somewhere, I think the main document is the GitHub, right?
Yes.
So if for each of these steps, if you add a comment on why this was done this way, then we might offer you some support in maybe developing this further, since this is a deliverable for the whole work package. So
yeah, I mean, at this point, it's a demonstration that is meant to show how an EGA could work. But yeah, absolutely, I'm very happy to receive any comments that you might have or any help you have. I will create an extra document and upload it to the GitHub, which not only shows the documents, but also the reasoning behind them. Mm-hmm. And then you can comment on that. That might be a good idea.
Yeah.
So maybe you can go to the GitHub. Actually, continue with that.
Yeah. Okay. So we are here. So we are assuming that we've downloaded a test file. How do I move it from the archive? Because that's all the archive.
Yeah, the submission might. Script will probably say it's already there.
That's how do I delete it from the archive? You can't.
I'm not dealing with that.
All right. Okay. So here is the file that we want to use. So first thing we need to do is to generate an MD5 sum for that file. So MD5 sum, and then the file itself. We're going to actually put the MD5 sum into a file called the filename.md5. And this is the unencrypted MD5 sum.
So the submission process expects the MD5 in a file with that name.
And then what we need to do is to encrypt the file itself using GPG. So we encrypt it with the EGA public key, just for the purpose of this demonstration. But you can use any key that you wish to define. Yeah.
Remove all the spaces.
Oh yes.
So the idea is in the future that all local nodes will have their own private key. And if I submit to your node, I'll encrypt the file using your public key. And here we provide a demonstration public-private key pair specifically for this demo setup. We should also start the tree.
Ah, yeah. Okay. So how do I do that? Yeah, how to do that? I'll do that. Okay.
So because we switched virtual machines, the Docker containers that we have started previously are all not running at the moment. They exist, but they are not running. So if you list the containers we have available to us, they should all show that they have exited. So you can see the status at the end of they have exited between minutes and hours ago. So we'll just have to restart each container. And we can do that with the command docker start, followed by the name of the container. So we'll start first by starting the database container again. So docker start EGA Pro. We'll restart this container. Then we are starting the Cypher resource. So docker start archive, followed by the API, docker start API. And the last one will be the FTP server. So this is docker start where's the name of it? Here, FTPD server. So docker start FTPD server.
So is the API on it? Okay.
Yeah. So now you can open the web page again to verify.
Yeah.
So we can verify that it's running by going back to the web page and making sure that this is running.
What?
API is down.
Yeah. I thought I got the API. Hang on.
Make sure it's running. Oh, it's exited.
Start API. EGA.
Do archive.
API.
Okay. And thus we built them. So do a docker rm API.
Yeah.
And a docker rm archive. And then do it, yeah,
Okay.
PSA. And now just run the two commands we used to start them up again. So the if you go to your So here, this
one?
this one.
This one, yeah. Instantiate.
Yep. Oh, our data-only containers are not.
Oh no.
Well, start the Docker. Do Docker start EGA private. Docker start EGA private. EGA dash minus. No, try that one. I'll do the API. Yeah, archive actually, no.
No? Maybe just restart. Do I need to?
There is something wrong with the command. I think you are pasting some. So you are saying docker start API docker run. I think there is some typo here. So there is no container called API docker run. So I think you are concatenating two commands together in the same line.
Docker start.
We welcome to your text file.
Yeah.
And copy the Docker run.
This one.
Not for the database, but for the archive Docker run.
This one.
Yeah. Then delete everything off. That's better.
Yeah.
And do the same one for the. Thank you. Do the same one for the.
This one.
API. That's better.
Okay. So now if I do Docker. Yes, say.
Yeah. Now you can try the web again. Yeah, that's better.
Okay. So we're up and running again. Thank you. Okay. So where was I?
You were encrypting the file.
All right. So that's now fully encrypted. So if I do an ls, you can see that I have the original unencrypted file, and I now have a .gpg encrypted file here. So the final thing I need to do in the file preparation is to actually then generate the encrypted MD5 sum value. Again, I'm going to put that into its own file, .gpg.md5. Okay, so I have three files that I will be uploading to the FTP server, the encrypted data file, and the encrypted MD5 and the unencrypted MD5 of that data file. So I can upload the file using FTP, using this command here. And because I've already used this VM to test the local EGA installation, the file is actually already on our server. So you can see I might actually be removed. Actually, does it remove? Let's just check. It may well have removed the file.
the do a Docker inspect ftpd underscore grep with that horizontal vertical line.
Okay.
IPA, capital I. So it's at 3 at this point. So when you do your FTP command, yeah.
Okay, so you can see that I've already previously uploaded the files here. They're already in the FTP account, the 3 files. So they are already there, so I can move on to the next step, which is actually invoking the archiving of that file using this command here. So this basically takes the file, it decrypts the file, and then generates...
Well, it takes the file, it checks the MD5,
yeah.
It decrypts it and re-encrypts it in one step with the archive key. It checks the unencrypted MD5, it creates the new re-encrypted MD5 file, then it decrypts the archived file to make sure the unencrypted MD5 is still correct. Once all of that is correct, it moves the file to the archive, and then it writes to the database the file information to make it available.
Sorry, could you show the command again, because I need to look at it. Could you show the command again?
Yeah, there you go.
Yeah. So which container is that? Which image?
So this is using our Perl image.
Okay, so this is the Perl image.
Yeah. So we are linking the database. We're linking the archive container. The name of our is Perl. We're getting volumes from private, from public, and then we're running this image, and this is the EGA Perl image we previously created to run Perl code specifically.
Mm.
And then the command that we run is enclosed in here. So everything, all of that is happening inside of the container then.
So where is the private key, the decryption key?
Well, let's see the local here. The private decryption key, this is something that is in part of the re-encryption service. It knows where to find it, so I don't have to specify it.
Okay, because you're specifying some EGA local private archives.
Yes. Well, this is the location of where we want to place it in the end. So the file is going to be placed in the archive, which in our case is in this path.
Okay, so this is the path of the file, not the path of the private key file.
Yep, this is the destination of the archived file.
And where is the connection to the service that decrypts the file?
So the re-encryption server the re-encryption service knows it has its own configuration file, and I gave it the location of the private key file in there. So I don't have to reference it in the actual command. The service already knows it.
This command, you are connecting to this service, right?
Yes.
And where is this part where you connect to this service, ask this service to decrypt this particular file?
Well, the submission key is always the same. So we have one private key, and all files we receive have been encrypted using the public key of that private key. So everything we get will have the same encryption. So I know that I have only a single private key that I can reference. The link happens here where I link to the archive container. So that allows me to make REST calls to the re-encryption service. And
Yeah, this particular part to make REST calls to the encryption surface. Where is this made in this command here?
Oh,
because this command, as I understand from you, it includes a request for decryption of the file as well, right?
yes, it actually runs a script file, a fairly long Perl script file, which is part of the code base. So you can look at the process file PL, and everything that is happening to this file, you can follow by looking what happens in this Perl file. So this is where all the REST calls happen. This is where the database interaction happens. The rest is configuration information for the script. So and you can find this actually in the EGA local.
Some documents in that file that tells about these steps. This step is for doing this. This step is for doing that. Because myself, I'm not very experienced in Perl, but I want to know how things are done. So I'm sure that this, of course, this Perl script is also on the source in the GitHub, right? But are there some notes inside the code that tells this part is for doing this thing? Or?
I don't know, since I didn't write this particular script, but I will make sure that we have documentation on that shortly. So we'll put documentation on that as well on the GitHub then.
Yeah.
Okay, so having run that command to archive the file, you'll then find the file in the private directory under archive. And here you can see the file has been archived and it's been re-encrypted with AES, hence the CIP suffix. So you have the file in the archive, and now obviously it would be useful to be able to access that file. And there's two ways that you can actually access that file. You can access it using the download streamer, which I will show you first. So this is a Java-based streamer. So first thing you have to ensure is that you have Java installed on your system. So I'll do that. I already have it, which is good. And then I can use the download streamer by pointing to it.
Make sure that the API is still good. Maybe do a Docker inspect.
Yeah.
The API and a vertical line and grep IPA. Okay, so this is 5 now. Yeah, you have. But yeah, when you run the streamer, you have to adjust the IP address specified then.
Yeah. Okay. So I can then log into the streamer.
Test EGA dashboard.
Okay, so I'm now into the actual download streamer, so I can access the file through this streamer. So here I can view the data sets that the streamer has access to. So you can see that I have access to one data set which refers to that particular file in the archive. So if I do a files data set and then specify the data set command, you can see that the file is here. You can see the makeup, the actual size of the file. This is the file accession. So all files in the archive are given a unique accession followed by the MD5 sum value of that particular file. So I can download that file by first making a request for that file. If I do a request file and then specify the file accession, provide an encryption key. So this is the key that will be used to encrypt the file, so that when I download the file, I can then decrypt the file using the key that I specified in the original request. And then I'm going to create a label for this download request so that I can track the request on the system. Okay, so having done that, the system confirms that I've created one request. I can then download that request by specifying the label.
Just do requests to see what's there.
Yeah.
Yeah, so request named label containing one file download request. So now we can say download.
Yeah. Okay.
And now you can, why don't you look at the encryption server?
Mm-hmm. Yeah.
So this is now. Yeah.
You can see the CPU's gone up here on the re-encryption service.
And also the network, the Ethernet. So you can see this happens at about 20 megabytes per second right now.
So once the file is then downloaded onto my local machine, I can then use the streamer itself to decrypt the file, just using the decrypt command and then specifying the key that I originally encrypted the file with. So that's one way in which I can access files within the archive. The other way is through the fuse layer. So using the fuse layer, I can access encrypted files in the archive, and I can have them displayed as being unencrypted in a directory that I specify. So I can do this using this command here. If I then go to the directory called mount point, I should then see an unencrypted copy of the file now in the directory. So here is the unencrypted copy.
So this file doesn't actually exist, but it's a view. So it's a real-time view of the file in the archive. Every access to the file is going to be on-demand decrypted. So it behaves just like an unencrypted file. And this would allow your local users access to your archive without having to copy and decrypt the file for themselves. So this is one way of being able to share the archive locally and not having to copy the files around multiple times.
So you see you see how we have set up the local EGA, and you see we've taken you right through to the actual testing the archive and actually accessing the archive, either using the download streamer or the fuse layer. So at this point, so this is basically the end of the example that I had to show you. Are there any outstanding questions that anyone has regarding the process itself, or technicalities regarding the process, etc.?
Could you explain the last part a bit about this view of the file? I'm not sure I got the picture correctly.
Okay, so where's your Okay.
So, next.
So this command basically runs a fuse layer, which means it creates a directory structure in an empty directory. And what is displayed in this directory is taken from the database. I'm specifying here a specific user. This program goes to the database. It looks up all the files that this user has been granted access to. It looks up where these files are located in the database. It looks which encryption key was used for this database in the archive, and then it mounts all these files into this empty directory. So it is a view of all the files for this user. Now, when I access this file in this mounted directory, which I put here, so when I access this file, then the fuse layer intercepts these calls. It checks whether the file you're trying to access is encrypted or not. If it is encrypted, it automatically decrypts the portion of the file that you wanted to see and returns them. So you can see here that, for example, I did a lookup. I looked at the size and so on. So these are all Linux operating system commands that were intercepted. And what happens in this directory then is that your file acts and behaves as if it were an unencrypted file. But in fact, it is everything you do with it comes directly from the archive. Every byte range you access is directly decrypted for you. So this never creates any caches or any local copies. It directly reads from the archive.
And the decrypted part, it's stored in the memory?
Well, it's being used by you. So when you list it, then it's displayed to you on the screen. If you're running SAM tools, then it's used by SAM tools. And whatever the program does with it, this will happen with the data. But the fuse layer itself will never cache any unencrypted data. So it's being created, passed on to the whatever it's using it, and that's it. There's nothing kept.
Yes, so are creating sort of a virtual file system using Fuse to...
Exactly.
So one could do something else, for example, just to display it in a database viewer or something, but you wanted to display it in a file system viewer, so in a file system-like format so that people could look at it as a file. That's why you used Fuse, right?
Yes, but not only look at it, but also use it. So you could now, for example, use whatever pipeline you have and use this as an input file, and it will work because it acts just like an unencrypted file. This means you can use your archived files, or your users could use the archived files without having to decrypt them first.